Hello student, welcome back to our M.Sc First Physics semester 2nd course, that is Atoms and Molecules, and our subject code is PSCT 122 and this is our 13th lecture. And in previous lecture we have started the IR spectroscopy. It is one of the spectroscopic techniques. In the third module of this course we have the different spectroscopic techniques. That is, the name of the module is the spectroscopic techniques. So we have a different spectroscopic techniques in that module. Generally here we have three different types of the spectroscopic techniques. First one is the microwave spectroscopy, or we call it as a rotational spectroscopy. Second one is the infrared spectroscopy, or also we call it as a vibrotational or vibrational rotational spectroscopy, and the last one is the third one is the Raman spectroscopy. So these are the three different techniques in this module we have to discuss, and in that we have covered the one spectroscopic technique, that is a microscopic or microwave spectroscopy or rotational spectroscopy, and we have started the IR spectroscopy in our previous lecture, and we discuss about the introductory part of the IR spectroscopy. Also we have studied what is the actual basic principle of the IR spectroscopy and why we call it as a vibrational rotational spectroscopy, and also we have studied the which molecules are IR active and which molecules are IR inactive. Now all those depends on the there is a change in the dipole moment due to absorption of the IR radiation, that means infrared radiation, and according to that we can decide which transition is IR active and which is not. So all those things we have covered in our previous lecture. Also we have studied about the different vibrational modes which leads to the IR absorption, that means the scissoring, bending, rocking, wagging, twisting, and symmetric or symmetric stretching. All those vibrational modes we have studied in our previous lecture. Now in this lecture we have to study about the, or we are going to study about the IR spectrometer, that means the IR spectrophotometer and its instrumentation and how it works. All those things we have to cover in this lecture. So let's start with the IR spectrometer or IR spectrophotometer and its instrumentation. The IR spectroscopy is generally divided into three regions: the near infrared region, the mid IR region, and the far IR region. As already we mentioned in our previous lecture also, the IR radiation is divided into three different regions, that is near infrared region, mid infrared region, and the far infrared region, and all those regions have different wavelength and hence frequencies. So according to that we get the spectrum. In a double beam instrument, the beam is split into two parts. One is directed through the sample cell and other through the reference cell. In the IR spectrophotometer we have to consider two quantities, that is our sample, and second one is the standard or reference cell. And here if we pass the IR radiation through these two, sample cell and the reference cell, that means the double beam instrument, that is the IR spectrometer is the, or IR spectrophotometer is the double beam instrument in which we are using the sample cell as well as the reference cell, and we analyze these two beam with the help of detector and another arrangement assembly, so that we get the spectra of IR spectroscopy. The two beams are then compared either continuously or alternatively many times a second. That means these two beams, that is the beam which passing through the reference cell and the beam which passing through the sample cell, both are detected or compared with the help of the detector, which is a continuously or alternatively. Thus, in a double beam instrument, the fluctuation in the source intensity, the detector response and the amplifier gain are compensated for by observing the ratio signal between the sample and reference. But why we are using the reference sample? Just why we not using the just sample? Because in order to avoid the fluctuation in the source intensity, that means there are some fluctuation in the source intensity or in the radiation intensity, and there is a detector response and amplifier gain are compensated for by observing the ratio signal between the reference and sample. That means if we take the ratios of signal of the sample and the reference, then we are able to compensate the detector response as well as the amplifier gain, and we are able to limit the fluctuation in the source. So in order to do all those things, we are using reference here, and we are detecting the reference beam and sample beam alternatively or continuously. So here is the benefit of using the reference cell. Now there are different parts in the IR spectrophotometer. The main parts of the IR spectrometer are as follows. First one is the radiation source. Second part is the four optics. Third part is the sample cells and sampling of substances. Fourth one is the monochromators. Fifth one is the detectors, and last one, sixth, is the recorder. So all those are the different parts of the IR spectrometer, and with the help of all those parts we get the IR spectra, and from the IR spectra we are able to study the different properties of that sample. So we will see one by one. So we start with the first is the IR radiation sources. IR instrument require a source of radiant energy which emit IR radiation, which must be steady, intense, enough for detection and extend over the desired wavelength. That means, as already we mentioned, any source of radiation in any spectroscopy must be steady. That means it emits the radiation in a steady way, and it must be intense. That means the intense for which we can detect the radiation, and the extend over the desired wavelength. That means the IR radiation is used such that it emits the radiation for a particular or desired wavelength. So these all are the different properties of the source. Here we are using the IR source, that is IR radiation source. So the source must possesses all those properties. Ideal source is a black body radiator, as it is difficult to have a perfect black body radiator. A source which will approximate to it is used. That means the IR radiation is nothing but actually the black body emitter. That means the black body which acts as an IR source. But the ideal source is the black body, but it is difficult to obtain the perfect black body. So we can use the approximate source to the black body, such as different types of the sources which are mentioned below. That means the most commonly used sources are the globular filament and Nernst glore. These are the two most commonly or widely used source. There are many sources of the IR radiation, but these two sources commonly used. Various sources of IR radiation are as follows. First one is the Nernst glore. Second one is the incandescent lamp. Third one is the mercury arc. Fourth one is the tungsten lamp. Fifth one is a global source. And sixth one is the nichrome wire. These all are the different IR radiation sources which emit the IR radiation with a desired wavelength or frequency. So all those sources are used as IR radiation sources, but in that particularly or commonly or widely used sources are globular filament and Nernst glore. So these are the most commonly used sources. Now the second part of the IR spectrophotometer is the four optics arrangement, and this four optic consists of again different parts, such as the first one is the source, second one is the mirror M1, third one is the mirror M2, and fourth one is the rotating mirror or chopper, and which is denoted by capital letter M. The mirrors M1 and M2 divide the source radiation into two equivalent beams of which one passes through the sample and the other passes through the reference. That means as shown in the figure, we have the figure or schematic diagram of the IR spectrometer. Here this is the 4 optics arrangement. It consists of a source. That means this is the IR radiation source, which may be the nichrome wire or nurse glower or anything else out of all those sources. That means, but commonly the globar filament and nursed glowers are used. So here is the IR radiation source, this source, and which emit the radiation in all those directions. But here we place the two mirrors, that is mirror M1 and mirror M2, so that the radiation gets reflected from these two mirrors and then again further processed. So these are the two mirrors, and there is a one again movable mirror, or we can use the chopper, and which is denoted by M. So this is the 4 optics arrangement. After that, the mirror M1 and M2 divide the source radiation into two equivalent beams, of which one pass through the sample and another from the reference. That means here the source emits the radiation, so that the radiation gets reflected from mirror M1 and mirror M2, and this reflected radiation passing through the one is passing through the reference and second one is passing through the sample, and after that these two beams are focused on the chopper or the movable mirror, and after that this is given to the monochromator or grating. So in this way the 4 optics will work. Now the next, ordinary lenses and mirrors are not suitable as a glass absorb the IR radiation strongly. The property of the glass material is that the glass material absorb the IR radiation strongly. So here we are not using the ordinary lenses and mirrors due to that property of the glass. Now the next and important part of the IR spectrophotometer is the third one, is that is the sample cells and sampling of the substances. IR spectroscopy has been used for the characterization of solids, liquids or gas samples. That means the 3 types of the materials, that is the solid, liquid, gases, are also used as a sample for the IR spectrophotometer. So first one is the solid material. Various techniques are used for preparing solid samples, such as pressed pellet technique, solid run in a solution, solid films, mule technique, etc. That means we cannot directly place the solid substance, or we cannot use the sample as a directly solid. It goes through the different techniques so that we get the proper spectrum, and these techniques are that is for the solid samples are pressed pellet technique, solid run in a solution, solid films or mule techniques. These all are the different techniques used to prepare the solid sample for the IR spectrophotometer. Now the second one is the liquid. Samples can be held using a liquid sample cell made up of alkali halides. Aqueous solvents cannot be used as they will dissolve alkali halides. Only organic solvents like chloroform can be used. That means for the liquid sample also we cannot use directly the liquid sample as it is. It is used, or it can be held using the liquid sample cell, and which is made of from the alkali halides like potassium bromide, and the aqueous solvents cannot be used, they will dissolve the alkali halides. That means with the alkali halides we cannot use the aqueous solvents, because the property of the aqueous solvents is that they dissolve the alkali halides. So we cannot use both at a time. So only organic solvents are used, and the organic solvents like chloroform is used. Now the third one is the gas. Sampling of gas is similar to the sampling of liquids. That means we use the liquid sample using the liquid sample cell. Similarly the gas sample is also used like a liquid sample cell, but here we use the gas sample cell. So procedure is the same for the gas sample also. So these are the 3 different materials used for the sample, that means these are three different, that is a solid, liquid and gas, and they used with the different techniques, or they are using with the different process, so that we get the proper spectra. That is, they do not use directly as it is, they go through the some processes, and after that we can use it as a sample. Now the next one is this is the schematic diagram of IR spectrometer, and this schematic diagram indicates the different components such as a mirror M1, M2, source, here is a reference, here is a sample, here is a chopper or movable mirror, and here is the grating, that is a monochromator, here is a detector, after that there is an amplifier, and here is a motor, that means the mechanical arrangement, and here is the recorder. So recorder record the signal and we get the spectra of particular sample. So this is the schematic diagram of IR spectrometer. Here we have a source, that is IR source, which is a nurse glower or another source which emits the radiation in the or infrared radiation, and these radiations are emitted and these are collected on the mirror M1 and M2. After this process, the M1 and M2 gets reflected these two radiation, that means the M1 and M2 divide these two radiation into form of two beams, and these beams, one beam is passing through the reference and another beam is passing through the sample, and these two beams are focused on the chopper or a movable mirror M, so that the movable mirror, again this radiation or these two beams are given to the or is able to given to the grating or monochromator alternatively or continuously depending on the requirement. So grating or monochromator monochromate the beam, and again this monochromated beam or collimated beam is detected by the detector, and after that the detected signal is given to the amplifier, and amplifier amplify that signal, and with the help of motor assembly here we get the or we connect all those things, and after that amplifying that signal there is a recorder, and recorder record the signal and we get the spectra or IR spectra of that particular sample. So in this way we are able to arrange the all components, and that is the schematic diagram of IR spectrometer. Now the next and important part also of the IR spectrophotometer is the fourth one, that is the monochromators. Various types of monochromators are used, such as a prism, gratings, filters. So all those the monochromators, the function of all those things is the same, but here we are using gratings, that is a diffraction gratings. Prism are made up of potassium bromide, sodium chloride or cesium iodide. That means these all are the different materials which is used for the construction of the prisms, and these prisms acts as a monochromators in a IR spectrophotometer. Filters are made up of lithium fluoride, and diffraction gratings are made up of alkali halides. That means if we use filters, the material used for the construction of the filters is lithium fluoride, and if we use the diffraction gratings, then the material used for the construction of the diffraction gratings are the alkali halides. So these all are the different materials used according to the use of prism, gratings and filters. So this is the monochromator part. Now the next part is the detector, that means the part which is used for the detection of the signal from the monochromators. Detectors are used to measure the intensity of unabsorbed infrared radiation. That means it is used to detect the intensity of the radiation, and after that detection we get the proper signal. Detectors like thermocouples, bolometers, thermistors, Golay cell and pyroelectric detectors are used. That means in IR spectrophotometer generally there are different detectors are used. In that we can use thermocouples, bolometers, thermistor, Golay cell. Generally Golay cell is used as a detector for the IR spectrophotometer, and after that pyro electric detectors are also used for the detection of the IR radiations. Now the last part is a recorders. The recorder are used to record the IR spectrum. That means the function of the recorders is used to record the IR spectrum, and after getting IR spectrum we are able to get the information about that sample. So in this way, this is the instrumentation or different parts of the IR spectrophotometer. Now how it works, that is the working of the IR spectrophotometer with the help of all those components. The source of radiant energy emits IR radiation. That means first component is our source, that is a IR radiation source, and which emit radiations, that means the having frequency and wavelength in the IR region. The mirrors M1 and M2 divide the source radiation into two equivalent beams, of which one passes through the sample and the other passes through an equivalent path and is called as a reference beam. That means as shown in the figure, here we have the IR radiation source, it emits the IR radiation. Here we have the mirror M1 and M2, so that the mirror M1 and M2 classify this IR radiation into two paths or two beam, so that one can pass through the reference and second one is a pass through the sample, and these two beams are focused on the movable mirror M or chopper. So this is the four optics arrangement actually, and this is the working of the four optics arrangement. So we get the two beams, that is a reference beam and sample beam. The two beams meet at the rotating sector mirror, that is a chopper, as already shown in figure. The rotating mirror alternatively allows the sample beam through the space or reflect the reference beam with the predetermined period to the monochromator slit, because detector receives the sample beam and reference beam alternatively. That means here as shown in the figure we have the rotating mirror here, and this rotating mirror alternatively or simultaneously used with the help of the predetermined period of the monochromator slit. That means the rotating mirror alternatively allows, not simultaneously but alternatively allows, the sample beam through the space or reflects the reference beam. That means at a time one beam is allowed, and this is according to the predetermined period of the monochromator slit, because detector detects the sample beam and reference beam alternately also. So this is the actually how it works. The detector detects the signal, and after that these signals are given to the amplifier to amplify, and finally recorder records the signal. That means here after receiving the beam here with the help of grating or monochromator, the beam gets monochromated, and after that this monochromated beam is detected by the detector, and this detector detect the reference beam and sample beam alternatively, so that we get here signal according to the sample or reference, and after detection this detected signal is given to the amplifier, and amplify the signal so that we get the proper signal, and with the help of motor assembly these signals are given to the recorder, and recorder records the IR spectrum, and in this way we get the IR spectrum with the help of IR spectrophotometer. So this is the working and the instrumentation of the IR spectrophotometer. Since both beams have traveled the same path length, compensation for extraneous effects due to the atmosphere etc. have been taken care of. That means if two beams have the same path length, then the compensation for the extraneous effects, that means some other parameters due to the atmosphere, have been taken care of. An infrared spectrometer analyzes a compound by passing infrared radiation over a range of different frequencies through the sample and measuring absorption made by each type of bond in the compound. That means in this way we know that there is an interaction between the sample and infrared radiation after placing the sample in a infrared radiation. So there is an interaction between the infrared radiation, that means as already we mentioned the condition for the infrared spectroscopy, when the absorption is takes place when the frequency of radiation, that means IR radiation, becomes equal to the natural frequency of vibration of that bond in that particular sample. So then and then there is an absorption and we get the spectra. So in this way we are able to analyze the component by passing the infrared radiation, but this is the over a different frequencies or different wavelength range from far infrared region to the near infrared region, and we get the information about the each type of bond in the compound. So in this way we have covered the working of the IR spectrophotometer and how we get the information about the each type of the bond in a particular sample. All those things we are able to study with the help of infrared spectroscopy. So in this way we have covered the basic spectrophotometer of infrared spectroscopy. That means up to this we have covered the infrared spectroscopy. In our upcoming video we will start with the some new topics.